Hi everyone, welcome to my video. If you have been following my previous video, you know that I am doing a course on UPSC previous year's question paper. So in this video, I will discuss Civil Service Mains Examination Paper 1st 2020. So you will read these instructions. You know this instruction is reads. So first question is here. A rocket starts vertically upward with the speed v0, then define its speed v at a height. So height h in the term of v0, h r radius of the earth, and g acceleration due to the gravity of the earth's surface. Also calculate the maximum height attained by a rocket fired with a speed of 19% of the escape velocities. And question number B is here. Determine the location of center of masses of the uniform solid hemisphere of the radius r and the mass from the center its base. So question number C. Next question number C. A rubber cord 1 mm in diameter and 1 meter long is fixed at one's end, and a weight of 1 kg is attached to the other end. If the Young modulus of rubber is 0.0 into 10 to the power 11 times centimeter square, then find the period of a vertical oscillation of the weights. And question number D. What are Newton rings? How are they formed by the two curved surfaces? And question number E is here. The equation for a displacement x of a point on a damped oscillator is given. X equal to 5 e per minus 0.25 t sin equal to pi by 2 t meters. Find the velocity of oscillating point at t is equal to t by 4 and t where t is the time period of the oscillator. What is the direction of velocity of each cases? And question number 2. Obtain the expression for a momentum of inertia of a solid cone about its vertical axis and axis passing through a vertex and parallel to its basis. Question number B. A shift of diameter 8 cm and length 5 meter is the transmitting power of 8 kilowatt at 300 revolutions per minute. If the coefficient of rigidity of the materials of a shaft be 8 into 10 to the power 11 times centimeter square, then the calculate of the relative safety between the end of the shaft. So this is Newtonian physics. And question number C is, what do you understand by length of construction? Calculate the percentage length concentration of a rod moving with velocity 8.0 c in a directional inclined of at 16 with respect to its own length. And question number 3 is here. Discuss the condition of interference, describe Young double slit experiment, and derive an expression for the estimations of fringe width. Discuss its difference on a various parameters. Green light of a wavelength 5100 ampere for a narrow slit is incident on double slits. If a overall separation of 10 fringe on a screen 200 cm away is 2 cm, find the slit separations. And question number B is here. So what is a zone plate? Give it a theoretical description. So that a zone plate has multiple foci. Differentiate a zone plate for a convex lens. Calculate the radius of a first half period zones in a zone plate behaving like a convex lens of focal length 60 cm for light of wavelength 6000 ampere. In question number 6 here, Brief discussion for postulates of Einstein's to explain stimulated emissions, drive an expression for Einstein A and B coefficient and show that the ratio of coefficient of spontaneous versus stimulated emission is proportional to the third power of frequency of radiation. Why is it difficulty to achieve laser action is in higher frequency range such as X-rays? Can this be a temperature at which the rate of spontaneous and simultaneous emission are equal? Illustrate with wavelength lambda is equal to 5000 amperes. And question number 4 is here. Derive the relativistic expression for a kinetic energy by considering mass variation with the velocity, hence establish relation between momentum P and energy E for a relativity particle dE by dP is equal to V. And question number B, 4b here, state and explain Fermat principle of extreme path. Discuss the cases of rectilinear propagations of light and reversibility of light ray. Context of Fermat principle. Using Fermat principle, deduce the thin lens formula. And question number 4c is here. Explain the phenomenon of double refraction in a calcite crystals. Considering refringed crystal as a non-conducting material, explain double reflection using electromagnetic theory. Calculate the thickness of a double refracting plate which produce a path difference of lambda is equal to 4 between extraordinary and ordinary waves. Given lambda is equal to 5819 angstroms or mu naught is equal to 1.53 and mu E is equal to 1.54. And question number section B, question 5a. A vertically oriented electric dipole having dipole moment P is kept at a height h above an infinitely large horizontal conducting plate which is ground as so in the diagram. Calculate the force between the electric dipole and conducting plate by using method of image. So given that provide image, conducting plate, ground state, so grounded, and B number is here. For the electric field given by E is equal to E0 E iota omega t, so that the conduction current is in a phase with the electric field while the displacement current leads the electric field by 5/2 radians, also so that the displacement current in a good conductor is negligible compared to the conduction current at any frequency lower than the optical frequency. F is less than equal to 10 to the power 15 Hz. And question number C is here. So here, based on the hysteresis slopes for a soft iron and steel as so in the diagram, which material would you prefer to utilize for making transformer cores and why? The soft irons. So this is the diagram figure. So steel and soft irons. And question number next is here D. State the first law of thermodynamics for a divisibly interacting systems. The temperature of 10 grams for air is rises by 2 degree at constant volume. Calculate the increase in its internal energy. Given Cv is equal to 0.17 kilogram per minus 1 C per minus 1. Question number is here. The energy level of a quantum harmonic oscillator with a frequency V is given by En is equal to n plus 1 by 2 h nu, where n is equal to 1, 2, 3. Calculate its partition functions. Question number 2. Calculate the partition function of a two-level systems. Question number 6 is here. Write the expression for a divergence and curly of an electrostatic field for the obtained Poisson and Laplace equations. So Laplace equation and Poisson equation find. Two concentric conducting sphere cells having radii r1 and r2, r1 is less than r2, are charged to potential v1 and v2 respectively, where are the electric potential and hence electric field in a space between the cells. Also find the charge on the inner cells. And question number B is here. Describe the oscillation of electric and magnetic field in an ideal LC circuit. The applied voltage phasor in a circuit 4 plus 3 iota volt and resulting current phasors in 3 plus 4 I amperes. Draw the phasor diagram, determine the impedance of the circuit and indicate whether it is inductive or capacitives in nature. Also find the power of dissipations in the circuit. Question number 6C is here. A free space show that electromagnetic EM wave is transverse in nature, so that the free space that the total outward flux of EM energy through surface as Poynting volume V is equal to the rate of loss of EM energy for the volume V. A laser beam of 2 mm diameters has average power of 20 gigawatt. Calculate the peak value of electric and magnetic field in the laser beam. Question number 7 is here. Discuss the principle of adiabatic demagnetization processes to achieve low temperature. Determine the fall in the temperature produced by adiabatic demagnetizations of paramagnetic metals in an initial temperature of 3 K when the magnetic field is switched off from 100,000 or state to 0, given the heat capacity at a constant magnetic field 0.2 joule gram kg per kg and the Curie constant per grams mole per centimeter cube 0.042 R K per minus 1 G per minus 1 OE per minus 1. So question number B is here. Starting from Maxwell-Boltzmann's distribution for a free particle in 3 dimensions, obtain the expression for a root mean square RMS speed of a particle. Calculate the RMS speed of nitrogen N2 molecule at room temperature 27 degrees Celsius. So room temperature is 27 degrees Celsius. Some other place write 25 room temperature, but here write 27. Question number C is here. Obtain the Clausius-Kelpian equation using this equation, so that for the phase boundary for a liquid and vapor phase PT relation can be written as B is equal to P0 E per minus L KT. Here it has been assumed that the latent heat L is independent of temperature, that vapor is treated as an ideal gas, and that vapors V is greater than V liquid, and the P is P0 as T infinity, temperature infinity. And question number 8 is here. A historic failure of classical physics is its inability to describe the electromagnetic radiation emitted for a black body. Consider a simple model for an ideal black body consisting for a cubic cavity of side L with small holes on one side. Assuming the classical equipartitions of energy, derive an expression for the average energy per unit volumes in unit frequency range. In what way does the result deviated for actual observation? What is the law called? Question number 2. Repeat the calculation now using quantum idea to obtain an expression to properly acoustics for the observed spectral distributions. Find the temperature dependence of the total power emitted from the holes. And question number B is here. Write the Maxwell equation in a free space in both differential and integrals from a plane wave equation, and so that the electromagnetic wave can travel in a free space with a speed of light. Can one get the wave equation for a internal forms of the Maxwell equations? And question number C. A 10 ohm resistor is connected in the series with a capacitor of 1.0 microfarad and a battery with EM electromagnetic force 12.0 volt. Before the switch is closed at the time t is equal to 0, the capacitor is uncharged. Calculate the following: the time constant, what fraction of the financial charge is 1, the plate at the times t is equal to 46 seconds. Question 3. What fraction of inertial current remains at the times t is equal to 46 seconds? Consider the inertial resistance of the battery is 0 and neglect the resistance of all the connecting wires. So question will be end. So I hope this video help for your coming soon examination, and so that is all related to this session. It for today. Thank you very much and best of luck.